Hello, everyone. In this episode, we'll continue from the previous episode, and we cleaned up the product description part. Now we'll do natural language processing, meaning we take the text, convert it to a numeric vector for each 10K filing, and then compute the cosine similarity that indicates how different two product descriptions are. Okay? And this is, again, the research by Professor Gerard Hoberg and Hoberg-Phillips from USC and Dartmouth to see how companies differ and make industry classification based on that. And the original research paper, if you're interested, is this one, A Journal of Political Economy. And it has many things. Let me just, maybe I should just show you here. Let's see. Okay, what they do, basically create documents of item 1 business description from the 10Ks. In this episode, we'll just retrieve 2 10Ks and cleaned up. One car company, Tesla, and another one, a pharmaceutical company. And then they do is that create a master list of vocabularies. So we compute all the valid vocabularies that we care, presumably nouns, and standardize it. And we have done this in the previous NLP lectures in the earlier episodes, so I'm not going to repeat too much, but we do this and create tokens. And then for each document, meaning the 10K, the business description part, we create a list of tokens, the vocabularies in that particular document. And then we create a matrix of presence of the token indicators from vocabulary 1 to vocabulary n, maybe thousands of them. And then the document 1 has here and nothing here and something and so forth. So it's a 1-0 indicator of whether a particular word is present in a documentation. Once we have these 2 row vectors, we can compute the inner product and then divide it by the norm, and that is the cosine similarity, which measures how different each documents are. Given that this was a business description, it basically indicates how different these businesses are. And the authors use that as an indicator for how similar industries are and make an industry classification for a group of firms. And they tend to predict well for various things like M&As and many other things. So, and here are some of the pictures taken from their article. For example, how many unique words are used in a business description? Typically, many firms, here's a histogram of that, around 200 words are used by companies. Different words are used in the product descriptions, although some firms use nearly 1,000 words and some use very few. And then here is just an example of how the cosine similarity or the use of words indicate how similar firms are or who the competitors are. For example, in this entertainment industry, the supermarket, it's Wanderlust Interactive, and it states of there are 43 rivals and these firms, and the SIC code is a government standardized code for industries. There are many rivals, but the kind of use of words, if you look at it, it turns out these companies here tend to use the same word. So, and that gives the idea of why don't we use the use of word in the business as an indicator for how similar industries are. And there are many examples that the authors point out. Eventually, this cosine similarity they compute using different methods. I'm not going to go through, you can read the original article for that. But basically, that TNIC, the text-based network industry classification, does a very good job with either the SIC3 or SIC4 digit industry classifications. It tends to correlate a lot with the typical industry classification, meaning that the use of words actually does capture some common similarity within an industry. Right? So let's see how this code works. So here is a code. Let's just put the library. And again, so I'm basically using the idea that Professor Hoberg and Phillips did. And then the NLP algorithms basically is similar to what we covered in episodes 58 or 60, or in recent years, Hugging Face is very popular, so you could have used this, although I don't do it in this. Let's import the libraries. And a critical library is, of course, the NLTK, the Natural Language Toolkit. And again, let's just remember from the early episodes, you actually have to install this NLTK package. I'm just gonna install just the popular ones, not everything. But that's enough for our purpose. Then let's load the data. So from previous episodes for Tesla and another company, I did cleaned up and retrieve the business section. So this is for Tesla. And then another one, this is Tricedia. It's a pharmaceutical company. I also cleaned that up. And it's here. So now we have text 1 and text 2, of these two documents. And here's the library function that we used in early episodes, episode 60. If you look at it, you will find a subroutine like this. This basically cleans up, if you take the text here, separate by words, make it lowercase, and then remove the stop words and all the stemming, the portal stemming. One more thing we do here is that because we care about the product description, we just care about the nouns. So this line, these last two lines will pick out just the nouns. But it's pretty much similar to what we did in episode 60. And then here we first want to get the master list of all the tokens, all the vocabulary used in both documents, in this case, the two documents. So I'm adding text 1 and text 2, and then combine them all. And then I'm going to basically clean the documents and create the tokens that just pick out the nouns. Okay, and then the vocabulary, how many do we have? We have 1682. Okay. And how many times they appear in that document and the product description. We just keep the minimum occurrence of 2, because it has to at least occur twice. Okay. And then save it in a hard disk drive, just in case you want to recycle it later on. So now there's a doctor line. Again, it's similar to what we did in the earlier episode 60 in the NLP. So clean the document for both documents and return the tokens. So this is basically getting the token for each. And then now that we have the token for text 1 and text 2 for Tesla and Tricedia, we'll create a master matrix of 1, 0 indicators for each tokens line up in a column and then the documents in a row. We create a 1, 0 variable. If a token, the particular word is present, then put 1, otherwise it's 0. So if you plot it, some are 1, some are not present, and so forth. Okay. Then finally, can you create a cosine similarity? The dot product, sklearn, scikit-learn actually has already a pre-made computing the cosines between two vectors. So we just call it up and call it similarity. And if you look at the two documents, it's basically 63% correlated. So this is how the things are done. You can, of course, do it for many, many more, like 100 of the whole universe of all firms in an industry and compute this. But this is basically to show how to compute the similarity of the based on the product of the text description of two companies. Thank you for watching this episode.